Today we would be beginning this chapter, workflow and business processes. In this chapter, we will learn about implementing workflow in an application. What is a workflow in an organization? Consider leave approval process. When an employee requests for a leave, that request goes to supervisor. If approved, it is forwarded to the HR department for its records. Simultaneously, the result, that is approval or rejection, is conveyed back to the employee. This is nothing but the workflow. If an employee place a leave request to supervisor, the supervisor forwards it to the HR department. This HR department records, make it record in its files, and further it will be informed to the employee whether his leave is sanctioned or rejected. Okay, so this kind of process we have to implement in an application, a software system. Let us design an application that implements this process. Here, leave request model. Here, there is a leave request. What are the requirements for this? You have to have an employee ID, request ID, details, status, approver means who has approved this leave request, and then employee has employee ID, employee details, and employee will work under a particular supervisor. And a supervisor is also an employee. One employee is approving the leave of another employee. So the approval, this approval, this approver is also an employee. So there is a connection. An approver approves. An approver is also an employee, and approval will approve another employee. And supervisor and employee ID has applicant. Means these two are connected because this employee has applied for this leave request for that purpose. This is nothing but creating UML classes, and this can be a UML class diagram, and you can write the code to have this process done by an application. So this leave request keeps track of the all the requests that are placed. Employee will capture each employee's supervisor as a self-referential foreign key. New leave request form using which an employee can apply. All these things are the details relevant while coding in a particular programming. Apparently, before programming, you have to have a diagram, class diagram. So this is a class diagram. And further, you can implement this in some programming language. That is workflow. Uh, Here, this workflow process. In an organization, you have workflow process and business process. A business process, as we go along, we will study. It also deals with the similar kind of thing wherein orders are placed and then um, orders are packed and orders are shipped, orders are delivered. So this diagram depicts the workflow. Here there is this user submitting a request, compute value of approver, send email to employee ID is equal to approver. This might be an approver. Approver can approve. After approving, forward this to HR manager and also gives the response back to the applicant. This is a workflow. Workflow meta model using ECA rules. Mm, Meta model in the sense that a leave application is a workflow. Like that, there are several other workflows. To model a workflow meta model is used. So there is a process, some activity is done, and after activity, it enters into a particular state, and that state has certain attributes. These attributes are stored in a table. This table data is presented in the form of a form, and this activity is performed by a actor with a particular role. Okay, activity performed by this actor with this having this role. Consider an organization where there is no software apps. It is done manually. How it is done? There are people, there are files, there are documents, there are some folders, and there are people who are performing for a particular task. All this now you are going to implement in the form of a software app which uh, models or renders a workflow. When it renders a workflow has got a process, and this process is performed by particular person, and that person is known as an actor when he performs a particular task, and while performing he plays a role. All these things are interlinked to carry out a particular task. Okay, this is the explanation of that. This is workflow model instance, one particular workflow, a specific case. Earlier figure illustrated a general workflow model. Here, this is a particular instance in which you have a form for new leave request, approve leave, record leave, view leave. You have different forms. What is a form? When you can see like this page, HTML page, or even you can create using Java or any language as such, .NET, C++. These are forms. And you can perform activity on form. What activity we can perform? New leave request means apply. Somebody is applying for new leave. Somebody will approve. Someone will record and someone will view. These are the activities. And then what are the states? State is nothing but the condition in which That leave request is in, it can be pending for approval, it can be approved, or it can be rejected. These are the status, different status. What are the attributes? Attributes: employee ID, the one who applies, and the one who approves. That is employee ID. That is an attribute. Why are we studying this? This question might come to your mind. Now, put yourself in the shoes of a programmer. Consider that you have joined a software organization as a programmer or a developer. This organization client has approached your organization for development of a software application that render this uh, uh, workflow and also implement that. For that purpose, you need to know, okay, how the things are done, how it can be made to done, and before writing the code, what sort of analysis work should be done. For that purpose, we are studying all this. Okay. ECA workflow engine. Let me see what they mean by ECA. Okay. Events, conditions, and actions. ECA means E events, C conditions, A actions. To model process is also referred to as ECA based workflow. Okay. Conditions are entry and exit states. Actions are email notifications being sent to users. So these might be the conditions. These are the actions. And activities and events are modifications to required values. So this events, conditions, and actions. Events, conditions, and actions to model processes. What process you are modeling? You are modeling here leave application. That model is known as ECA because it is based on certain events and conditioned on conditions, in the existence of some conditions, and some actions are being taken. I hope it is clear now. So in this ECA based meta model 15.3, this one, in this model a process is implemented like when okay here let me bring to you one important point. When you do a project in your next semester, you have to write your project details also in this textual format. If you do this, you gain insights into the project. You have to write in this manner: a process instance comes into existence as soon as the form corresponding to first activity is executed. For example, when a record is created for leave request through new leave request form. This is nothing but the description of the software application that you are developing. You have to be very thorough in this. If you can describe it, you can code it, and you can bring a really good system on the table. After every transaction, any form associated with workflow activity, a generic function is invoked. This is describing the system in text. All right. Workflow update. WF, workflow update. It takes an object as parameter. What it is doing? It is taking activities, initializing the ready list, and for all entry states, no exit state is true. And then you are adding that activity AI to R, that is ready list, and performing that list of roles that can perform that activity, and then inform or send notification defined, then get actor, and if actor play role, send an email. Okay, this is how you have to. This is analyst job. An analyst will do all this. Actually, developer has to just write the code, translate this text into code. Analyst performs all this, and analyst is extremely important job in any software development organization. The one who understands everything and then come up with this type of details. That by looking at this, you can write. Can you translate this into code? Yes, it's very easy to translate this into code. Here you can take an array. Here, here also you can take an array or a list, and then you have to take a for loop, another for loop, add the activity into the that list, and take another loop. This kind of uh, description about a function can be directly translated into a code in any programming language quite easily. If you understand this, if you can do this, then it would be good for you. All right, this is all description about that. Next is a function my underscore work list, which is taking the parameter user u. In this, what is happening? It is actually work list computation. R, what is R? All the roles. Consider you. You consider yourself. Okay, each one of you. Consider yourself, say John, Alice. This Alice will have a role of, say, manager. Alice is also, say, an analyst. Alice is also, say, project leader. Perhaps these are the role Alice is performing. So all the roles played by user U. If in place of you, if you place A Alice, then you get these three roles. A, all the activities that are performed by roles in what managers have to do. You have all the activities that manager can do. Manager will sign contracts. Manager will assign projects. Manager will deliver the systems to the clients. So what are these three? These three are the activities performed by manager. What an analyst will do? Analyst will come up with the description, with the classes, with the uh, important systems and subsystems. And what does project leader do? A project leader perhaps is dividing the project tasks into multiple subtasks and allotting to each project member. All this Alice is doing. In small companies, this happens. One person is playing several roles and doing several tasks. So, all that are nothing but activities. And what you have to do for each activity A in the list of activities, capital A, compute entry state, compute exit state. When you enter into signing of a contract with another client or another, company. And when it ends, what is exit? Let O be the list of objects containing states of A, and we have to search all the instances of O, instances in O where all entry states are satisfied. If an entry state is satisfied, then enter in this and then add A to O. Means in this there will be some objects. For instance, you are signing a document, you have a soft copy of the signed document. So that is an object. So that object you have to add it to A, activity A. This is workload computation. I hope it makes sense. This is really important for you all when you are doing your project. You all have to do analysis part. You all have to think about what are the classes, what are the objects, what are the methods, how these objects will communicate, how message passing happens, what are the states. Everything you have to first document and for subsequently uh, write the code. You don't start writing the code from scratch. At the initial stage of your coding or doing project, you have to first come up with this documentation using an external workflow engine. When transactions from multiple applications including enterprise software such as ERP systems need to be invoked by the user, an external workflow engine becomes essential. When multiple applications are interacting, it's not about just a single application. When multiple applications are interacting this scenario, you need to have a external workflow engine, and the interaction between an application and a generic workflow implementation, these are the tasks. Updating is what determining what activities are next, what has to be done next. Notification means signaling users about the tasks that are pending. These are multiple applications. There is a wrapper around this, which is an external workflow engine. That external workflow engine ensures that um, there is an updating of the activities, notifications are being sent, and work list is being created. Work list having users uh, and their tasks, and then users can view all the tasks that are pending. All this, when you have a software system in place, these things will be carried out by the system itself. Essentially, here the workflow engine. This navigation is it enables user to navigate to the appropriate application form. There are several applications, there are several forms. To which form that navigation can be done by the user through this external workflow engine. This is the diagram that depicts that external workflow engine. Here there is an application data, there are process instances, process model, and this workflow engine, this is an external workflow engine. It's not part of an application, it's outside an application, essentially performing the tasks of updating, navigating, invoking, sending notifications and all. Process modeling and BPMN. So what is BPMN? Business Process Modeling Notation. BPMN. It is a graphical notation to capture process behavior. How a process is carried out, that behavior you are capturing in business process modeling notation. So consider a business. Consider a business of, say, car showroom. Suppose if you have a business wherein you sell cars, you have a car showroom. That's a business. And then there are a variety of processes that are done in that business. It's not that simple, just to say it is like car selling showroom, but then a lot of uh, work goes behind that, to have this orders placed to the manufacturers, or to receive the orders from the clients, to arrange the cars of uh, customers choice, and to you know deliver the product or the car on time. There are so many things that business is doing. And business also does advertisements. So many things are involved, so that business process modeling notation is a graphical notation to capture this process behavior. Look at this. This is like leave request process. Likewise, order receiving process, order placing process, and then order delivering process. So what is this process? You have got employee, you have got supervisor and HR manager. Employee will apply, supervisor will approve and record in this HR manager's office, and also intimate the employee. This is the process. This is uh, do you know that there are this diagrams, 9 kind of UML diagrams, in which you have this sequence diagrams. This is nothing but a sequence diagram where it shows how request is processed, in a time ordering manner. This is with respect to time. Sequence diagram models the behavior with respect to time. This is the event that has occurred first, followed by this, subsequently this and this. No, this diagram clearly shows that approve is not the one which has commenced this whole process. It is apply that has started this process. So then you need to render this for every business process you have to have like this type of sequence diagram. All right, and then this this one will show. Okay, this is leave request process. That process is being shown because we know that this business process modeling notation is a graphical notation. We are coming now to this graphical notation to capture this behavior. So this process, this sequence diagram, you are modeling here as BPMN model. Here you have HR manager, supervisor, employee. This is like, okay, activity diagram. It resembles like activity diagram. There is a start, there is a stop. In activity diagram also you have a start, stop. Then you have activities, actions, transitions, okay, and then you have these comments, and you have decision box. In UML, you might have learned about this activity diagram. This BPMN model is like activity diagram, where an employee is starting this process by applying for the leave, and here it comes to the supervisor who is approving, and and then informing the, there is a decision here. What is the decision? That leave request is approved. When leave request is approved, it has to be recorded and it has to be sent back to the employee. And you see, this is a dashed box. What does it denote? It denotes one, uh, component that encompasses two different tasks: approve and find replacement. Approve only on the condition that there is a replacement. Suppose, as a faculty, tomorrow I have a class and I want to leave, and I apply for the leave. What happens then? Uh, Principal, before approving, would try to look for an alternative or a substitute or a replacement. So, if my class is at 10, is there anyone else free at 10 o'clock? If yes, then allot the work to them, and then uh, approve my leave request. So these are based on condition. If there is no replacement, obviously leave might be rejected. It is apparent that work will get disturbed, and if the reason for your leave is also not that strong and there is no replacement, here this is known as BPMN model for leave process, and this is a graphical model. All right, and then BPMN model with transactions. Oh, look at this. Now the complexity has accelerated to a great extent. So what is happening here? This approve. This is just the expansion of approve activity, and this is the expansion of find replacement activity. Inside that approve, look at this. How many things have to be done? Business, every business process is a very complex and complicated activity. It's not simple. So this can be clearly seen here. It is evident that to approve, review the request has to be done, then leave balance, whether so many conditions have to be checked, not only just replacement. you know Whether the leave applier has got adequate leave balance or not, and what is the duration. Again, there are certain conditions. An employee cannot take a leave for more than a week during the semester. No, once the semester ends, employee can avail 2 weeks or 3 weeks and even 1 month leave during preparation holidays or summer time. But then during the working period, it cannot be granted. So that condition and decide the request, whether it is denied or approved. And then when a replacement is searched, whether replacement is found or now not. If it is found, then whether then this activity assignment of the task has to be done. And then when once employee is back, assignment has to be replaced, I mean release. Well, you see how difficult it is to write the code. That's why, you have to do lot of analysis. You have to study the problem so thoroughly before writing the code. If you just sit and start writing the code, you will not get those many ideas. But if you analyze the system, if you study, suppose if you are writing the code for a hospital, if you go to a hospital, talk about the stakeholders, you will get so many conditions, so many events, so many actions, so many activities, so many rules, so many guidelines. All you have to incorporate into your software. That's why it is a good idea to do a project in a domain in which you have a solid knowledge. Okay, now coming to this workflow in the cloud. We have learned about workflows in an organization, how it can be modeled, and so on. Moving in that same direction of learning workflows, here in the cloud, here it's not a normal organization wherein they have their own servers and then everything is within their premises. It's not like that. Now it has come out, it has gone into the cloud. So workflow in the cloud. So we know that we have Microsoft Azure as a cloud, and this Microsoft Azure .NET services uh, are provided in the form of service oriented workflow, and many dev2 platforms such as instant apps and force.com also include workflows in their meta models. And workflow can be, and it is actually an ideal candidate for cloud deployment. Workflow services are quite easy to deploy uh, in the cloud. And okay, so with this we have done with this chapter. To Monday, Monday I'm not taking class. I think Tuesday we will look at this enterprise analytics and search. Any doubts in today's class? Students, does anyone have any doubts related to cloud computing or anything? You can ask. Okay, as you know that your semester is going to end, I suggest you all to start looking for a good project, looking for a good technology to learn, and start that. Okay, students, then I wish you a very happy new year. Bye bye.